So for each one of these, what we want to do is we've given a sequence of numbers, and we want to determine if it's arithmetic, geometric, or neither. Right? For now, for these first couple problems, we just wanted to say if it's geometric, or if it's arithmetic or geometric. That's all we want to do. Okay? So if I look at number 1, okay, I go from 0.75 to -3, from -3 to +12, from +12 to -48, from -48 to 192. What do we think this is? What? All right, so we say first guess is, just by looking at it, first guess is it's geometric. All right? Let's determine that. So in order for it to be geometric, we need to have a common ratio. Okay? So if I want to find the ratio between these two, -3 divided by 0.75, what's that equal? Use your calculators, please. Yeah, don't sit there and try to think about doing it by hand. -4. Okay. What is 12 divided by -3? -4. -48 divided by 12? -4. And 192 divided by -48? Yep, -4. So yes, even though this is a really wonky one, this is absolutely geometric. Okay. Let's look at number 2. Okay. Number 2, we have 3 5/8, 7 over 27, 9 over 64, 11 over 125. Does this look geometric, or does this look arithmetic, or does this look like neither? Anybody on Zoom? Well, it doesn't really look arithmetic, right? Because if I look from 3 to 5 over 8, right, I'm actually subtracting a big number. Okay? But look at the difference between each of these: 5 over 8, 9 over 64, 11 over 125. It doesn't really seem like it has an arithmetic pattern, right? I mean, what's the difference between 3 and 5/8? So 5/8 minus 3 is equal to what? Is equal to 5 over 8 minus 24 over 8, which equals negative what? 5 minus 24. So it's minus 19 over 8. Okay? And then if I took 5/8 and minus 19 over 8, I'd get negative 14 over 8. Right? And so on and so forth. So this pattern doesn't actually work. Okay? So it's not arithmetic. So let's try geometric. Okay? I know this is going to be weird, but what's 5/8 divided by 3? Anyone? It's 5 over 24. Okay? Let's look at what's 7 over 27 divided by 5 over 8. All right, just really quickly, right? This is the same thing as 7 over 27 times 8 over 5, which gives me 56 over 135. Now simplify that. What do we get? Can't really, I mean, we can try to simplify this. I mean, what do we have in here? I don't even think 2, not 2, 3, 5. Yeah, it doesn't really look like it's super simplifiable, right? Let's see, 56 divided by 7. Yeah, because I can't find a common ratio between those two. So essentially what we've just shown is that this is actually neither. Okay? I'm going to give you guys a few minutes, and I want you to try and do 3, 4, and 5. Okay? Just do 3, 4, and 5 on your own. I'm going to give you guys about 3 minutes. Okay? Try and do 3, 4, and 5 on your own. About 2 more minutes left, guys. Again, you're just doing 3, 4, 5. That's all you're trying to do. All right, let's take a look. Okay, if we look at number 3, okay, again, we're going negative, positive, negative, positive, negative, right? So at best, right, this thing can't definitely be arithmetic, right? Because if I add a constant number, I'm never going to go from bottom to top, from bottom to top, right? So I'm never going to go positive, negative, positive, negative. The only ones that can possibly do that are geometric, okay? So again, what I want to do is sorry, I should be using green. What I want to do is I want to see if, okay, what's the possible common ratio? So 2 over negative 0.5 should be, I think it's 4. Yeah, negative 4. Again. negative 4. Then I look at negative 8 over 2, which again equals negative 4. 32 over negative 8, which again equals negative 4. And negative 128 over 32, which again equals, yep, you're right, negative 4. Okay? Which means that this thing is geometric. Okay? What about number 4? Did anyone get what number 4 is? All right, we got one for neither. Let's look. Okay, if I look at the common difference, 4 plus 2 is 6, but 6 plus 4 is 10, so it's not arithmetic. Let's see if it's geometric. 6 divided by 4 is equal to 3 over 2. 10 divided by 6 simplifies down to 5 over 3. Okay? So this is absolutely neither, because it doesn't have a common difference, nor does it have a common ratio. Okay? What about number 5? Number 5, right? So if I look at 2/3, if I think about, well, okay, again, it looks like it might be geometric just because the denominator shifts, but let's kind of think about the common, let's look at the common difference. If I take 13 over 6 and I subtract 2 over 3, which becomes 4 over 6, right? The common difference here becomes what, 7 over 6? No, 9 over 6. 9 over 6, which is the same thing as 3 over 2. If I look at 11 over 3 minus 13 over 6, okay, that's the same thing as 22 over 6 minus 13 over 6. 22 minus 13 is what? 9 over 6, which is the same thing as 3 over 2. Okay, so believe it or not, right, this thing is actually arithmetic. Okay, and my common difference is 3 over 2, or 9 over 6. Okay. Number 6, you should hopefully just be able to tell right away. This is what? What? Why do you get neither? Okay. Okay. Anyone else? It's actually arithmetic. Okay. This is actually arithmetic. Okay. Just because, remember, arithmetic, right? The formula that we have for it, if we're going to go a to the n that way, right, is because, again, we're probably using, oh, shoot. Let's move this over here. If I have arithmetic, right, it's of the form a to the n is equal to a to the first plus n minus 1 times my common difference. Okay? There we go. Okay? Now again, n minus 1 times whatever my common difference is might end up giving me something that looks like 2n. Okay? Geometric. Shoot, I've been using green for geometric. Geometric right, has the form a to the n is equal to my first term times r to the n minus 1. Okay? So let's look at number 7. Number 7 is clearly, is it arithmetic or geometric?
Geometric.
Geometric. Okay. Number 8 is arithmetic or geometric, guys?
Arithmetic.
Arithmetic. Okay. Number 9, geometric. And number 10, arithmetic. Okay. I went all crazy with the colors there. I don't know why. Right? So, just keep in mind that these are the two formulas that we're really kind of focusing on. Okay? Now we're going to determine if it's arithmetic, if it's arithmetic. All we're going to do is determine if it's arithmetic, and if it is, find the common difference, then the 52nd term, and then state the formula for the general term. So there's lots that we're going to kind of do in here. Okay? So first thing is if we want to know if it's arithmetic. So I'm going to determine, again, all I need to look at is the common difference, because all we're asking for if it's arithmetic. We don't care if it's geometric or not. So if it's arithmetic, I'm going to go, okay, well, what's the difference between negative 24 minus negative 31? What's negative 24 minus negative 31? Seven. Yep. What is negative 24 minus negative 17? Negative 7? It's positive 7. Wait. Hold on. I think I messed something up. Yeah, sorry. I screwed that up when I did that the other way. It should be negative 24 minus negative 31, which is 7. And this one should be negative 17 minus negative 24, which is 7. And then this one should be negative 10 minus negative 17, which is also 7. Right? So it is arithmetic. D, my common difference, is 7. Right? We want to state the formula for the general term, so we're going to go a to the n is equal to my first term, which is negative 31, plus, right, n minus 1 times d, which is 7. Okay? Okay, and again, another way that you can kind of, and this is kind of where it gets a little weird, is you can actually, and again, we're going to leave it like this, but if, for example, if I FOIL this, not FOIL this, but if I distribute this, plus 7n minus 7, right, this would become negative 38 plus 7n, okay? So that could be the general formula. But I don't like using that, right? Because that assumes a term in here that we haven't actually used yet. Or that's not even in part of our sequence, right? So I'm just going to leave it as this. And then if I want to find my 52nd term, I'm looking for a of 52, which is equal to negative 31 plus 52 minus 1 times 7, which is equal to negative 31 plus 51 times 7, which is equal to negative 31 plus 357, which is equal to 326. So 326 would be my 52nd term. Okay? So all of these are part of that answer. Okay? Number 12. 9 minus 13, which would give me what? Negative 4. 5 minus 9 is equal to negative 4. And 1 minus 5, which would give me negative 4. So this is arithmetic. D is equal to negative 4. My general rule would be a sub 1, which is 13, plus n minus 1, which is, or n minus 1 times negative 4. Or another way we could write this is negative 4 times n minus 1 plus 13. Actually, no, we're not going to write it that way. I'm sorry. I feel like that's just a little too confusing. What just happened to my display here? Okay, there we go. We could just write this as 13 minus 4 times n minus 1. Okay? Either one of those two will work. Okay. So now if I want to find a sub 52, this is 13 minus 4 times 51, which will give me 204. So this is 13 minus 204, which is equal to negative 191. Okay? And then you can do the same thing with geometric. Okay, I'm going to do one example of geometric before I let you guys go to work on your assignment today. Okay, because you can do the same thing. You can actually complete this on your own. Do number 13 on your own, and then you can do number 15 and number 16 on your own for geometric. So we just want to determine if it's geometric, find the common ratio, the eighth term, and the formula for the general term. Okay. Number 14. 16 divided by 4 is 4. It's my common ratio so far. 64 divided by 16 is 4. 256 divided by 64 is 4. So this thing is geometric. Right? I put D. Its common ratio is 4. Okay? And its a sub n is equal to my first term, which is 4, times my r, which is 4, to the n minus 1. Okay? And again, you can hopefully you're seeing that this is actually 4 to the nth power. Right? This is all of my powers of 4 so far. So I'm just going to write this as kind of like a green to show that it's a little bit different. This is the same thing as 4 to the n. Right? 4 times 4 to the n minus 1, 4 to the n. Okay? But we're going to focus more on using this formula. So if I want to find the eighth term, is equal to 4 times 4 to the 8 minus 1, which is equal to 4 times 4 to the 7th, which is equal to, oh shoot, why is my screen glitching? So my eighth term should be 65,536. And that's kind of how we can do this. So please remember your rules. I'm going to let you guys go ahead and work on your assignment for tonight. If you have any questions, please feel free to speak up. You can also email me and sign up for office hours. But otherwise, I'm going to stop this video. I'm going to post them both. And I'm also going to post the what we've just kind of worked on. I'm going to also post this worksheet with its solutions a little bit later today. But I'm also going to post the green notes that we took at the very beginning. Okay? All right. Anyway, please go ahead and get to work, guys.